All right, this lesson is on simplifying rational expressions. So that's where we're going to start. What is a simplified form of the expression? State any excluded values. All right, so the first thing that you're going to want to do is, if you can, factor out anything from the denominator. All right, if you can't, then that's fine. I can pull out an a squared, and I'm left with 7a. Okay, so that's what I'm dividing out. If I can divide it out here, I can probably, and I can, factor it out or divide it out of the numerator here. So I'm dividing out that common factor. Here's my common factor, a squared. 7a is left on the bottom. And if I divide it out, remember we just subtract those exponents. 2 minus 2 is 0, so I'm just left with 21 over 7a. And then I can reduce the 21 and the 7. I can divide out a 7. So I'm left with 3 over a. Okay. Now, it says when you state any excluded values, an excluded value is a value for a variable. So a variable when the expression is undefined. Is undefined. Okay, so in this case, in order to make this value undefined, my variable would have to be 0. Okay, so a cannot equal 0 because that's what would make my expression undefined. So that's the definition of your excluded value. All right. Let's move on to number 2. Okay, the first thing that we're going to do is see if we can factor anything out. I can pull a 4 out of each of those. Let's see. But I'm not going to be able to pull it out of the 18. So I'm going to look at something that I can pull out of all 3 of those. Okay, so I can pull out a 2. So let's divide out a 2 from everything. So on top, I'm left with 9d squared. And then I'm left with, I'm dividing out a 2. So 2d plus 4. And I can't divide out a d because this value right here doesn't have a d with it. So then I have to look for my excluded values. So what will make this denominator 0 is essentially what we're looking at, because that will make this expression undefined. Well, I need this 2d plus 4 to equal 0. If I plugged in a -2, so -4 plus 4 equals 0. So the d, the excluded value, d cannot equal -2. Sorry, I don't know what's happening right here. Let's fix this. Okay, sorry about that. Okay, so now we're under the containing a trinomial flat. We need a simplified form of this expression stating any excluded values. The first thing that we're going to do is factor. So I'm going to be able to pull out a 2 on top, and I'm left with x minus 4. And I'm also going to factor the bottom. So what multiplies to negative 8 but adds to negative 2? X minus 4 and x plus 2. All right, now I'm going to cancel out anything that I can on top and bottom. I can divide out that x minus 4. So I'm left with 2 over x plus 2. And that's as simplified as I can go because I can't divide out a 2 from this x. So now I need to state any excluded values. From the original equation, so technically right here, but after it was factored out, what are the two numbers that I can't have x be? Well, I can't have x be a positive 4 because 4 minus 4 is 0. So x cannot equal 4. And x can also not equal a negative 2 because that would zero out the bottom portion of our complex fraction there. All right, so then the next one, I'm going to do the same thing. I have to factor out on top, multiply to 2, add to negative 3 will be a minus 2 and a minus 1. And then see if I can pull out a GCF of the bottom. I can pull out a 3. I'm left with a minus 1. Okay? Again, dividing out. I'm left on top with a minus 2. And on bottom, 3. Sorry. Now my excluded values. What can a not be if it to make it zero out, which would make this an undefined rational expression? A cannot equal positive 1 because 1 minus 1 is 0. 0 times 3 is still 0. All right, good. All right, and the third flap we're looking at is opposite factors. Okay, again, we're going to simplify any of the fractions that we have here using opposite factors. So what you need to do is pay attention to number 1. We see that we have a 2x minus 5, and on the bottom we have 5 minus 2x, which is almost the same thing. So we have common factors there. There's nothing I could have factored out. In order to change this bottom fraction to make it look like the top, bottom binomial to make it look like the top, I'm going to divide out a negative 1, not from the top, just from the bottom. Okay, so then it can switch around. So then it's actually 2x minus 5. Because dividing out the negative 1 will make that a positive and that a negative. And then I can just rearrange the order using the commutative property over, so I pulled out that negative 1, and I'm left with the 2x minus 5 on top. Well, I can now cancel out those common expressions, and I'm left on top with 1 over negative 1, which is really just negative 1. All right, and then we got to state anything that's excluded. All right, so that means that we need that this bottom cannot, the original bottom cannot equal 0. All right, so 5 minus 5 would equal 0. Well, what would x be in order to make that 5? Well, half of 5 is 2.5. So if I multiplied 2.5 by 2, that's 5. So 5 minus 5 is 0. So x cannot equal 2.5 because that would zero out the whole bottom. And this number 2, similar here. I'm going to be using opposite factors, but I can see on the top here that I can factor this out. This is a special product. So what multiplies to negative 16 but adds to 0 since there's no middle term? Y plus 4 and y minus 4 over 4 minus y. We can recognize those are opposite factors. They're just switched around. So I'm going to divide out a negative 1. And that allows me to switch it back. So now I can have y minus 4 and leave that rest on top. Y plus 4, y minus 4. Okay. Now you can cancel or divide out those common factors, and I'm left with y plus 4 over negative 1, which is just negative 1 times y plus 4, and I can even simplify that by distributing negative y minus 4. Okay? Good? And now, so that's my answer. I need to find any excluded values. So 4 minus what will zero out the bottom? Well, 4. So y cannot equal 4. That's my exclusion. We're going to do the last word problem together because we're going to draw a picture, and I'll explain it a little bit more in depth in class. If you'll go ahead and copy this down on a clean sheet of paper, because I have your interactive notebooks, you're going to first simplify each of the expressions. They're each like the ones that we did in class, in the foldable. This was simplifying rational expressions. This was containing a trinomial, and the last one was using opposite factors. Okay, so there's one of each type, and then I also want you to list the excluded values for each of them. You need to do all of that in order to receive full credit for your homework. Okay, if you have any questions, you can email me. The code word for this lesson is Wildcats.